Welcome to Vincit Co-op here at Steissi. I'm Emily, and I work here. And yeah, that's pretty much the intro of the company that I think you're all really actually interested in. Of course, we're hiring. I mean, duh. So feel free to talk with us about that if you're really interested. But mostly we're here because, hey, why not? We have this great space to use. And if we arrange a nice event for you, we also get some nice food. And there's other side benefits like that. Also, I slightly occasionally like hearing the sound of my own voice. So here I am.
Good thinking.
Thank you. So again, welcome to React Helsinki here at Vincit. We have 3 talks today. Myself and
Rita. And third one is yeah.
Jonas is technically the organizer of this event. Plus Alex, yeah. But yeah. So because I'm here and because I have at least some of your attention, I figured it might be easiest if I just keep on going and start with my talk. I like playing with new things. And one of the newest things to come out is the 16.3 release of React, which I kind of hope at least some of you have heard about. This is going to be relatively technical because I'm going to be diving into the code of what I've done with the context API that came along with the 16.3 release. Could I have a show of hands of who here has actually heard of this of the new context API? Keep your hands up if you've actually done something with it. That's cool. Is there someone here who has no idea what I'm talking about? Okay. Short version is React has not had a context API that's been public since ever until now. There has been a context API, but it's been a bit clumsy to use and not really entirely public. And what we've got now is an API that's much, much nicer to use. And in my honest opinion, is going to replace a lot of the use that Redux, for instance, is used for at the time. This is the entirety, honestly, of the API that's now come out. There's a new method on the React object, create context, that you can give some default value. You don't have to. And you get out of that a provider and a consumer component. And then the way you use them is that you put the provider object on the outside and the consumer object somewhere on the inside. Now the consumer, or the multiple consumers, can be at any depth within the structure, and they still get the value that's being given to the provider at the top level. So you can have a top-level API getting some data for you, pushing it into the provider, and then you can get it out at the consumer level. And effectively, it means that you don't have to pass stuff through the props or through a Redux store or otherwise. And it's really quite nice. So the provider takes in a value parameter, and then some child object or objects. And then the consumer itself takes in no properties itself, but its child must be a single function that gets as a single argument for that function the value that you put into the provider. The reason why you need to have this React create context call at the beginning is so that you get this pair of provider and consumer. So it's specifically this consumer is a consumer for this provider. And then you can do the same call in other places and get a different pair of provider consumers, because it's quite likely if you go down this road, you're going to have a number of different provider consumer pairs. And what I've done with it is I've put together a small library that's actually released now, React message context. And I've tried to be sort of Reacty about its design, so that's the entirety of its API. So the message provider is a wrapper around the provider object, and it takes in a messages object of different sorts of messages. The whole purpose of this thing is to provide a way for you to define in one place the messages that you've got that you want to show in your UI, UX, and then to be able to access those messages from elsewhere. React Intel is one of the most used components that does a lot of the same things as this does. React Intel does many other things, but this does specifically messages and just messages. And then for the provider, in addition to the messages object, you can use it with a single locale, but this is really designed if you're working in a multi-language system. Say you need to support both Finnish and English. You need to be able to have messages in your UI that are both in Finnish and in English. And this allows you to have a messages object that holds both of those messages. And then to define some set of fallbacks and the specific locale that's the current locale that you're using. And then within that message provider's child objects, you can have these messages. And then with the ID parameter, you can refer back to where in the messages this message came from. You can define a specific locale. If you want to normally have your app using one specific locale, and then in a specific message you need to get from a different locale, you can do that. And then if there's an error of message not found or something, you can define a callback for that, and then you can pass in some properties. If the message is a function, so that can be parameterized, you can pass that in with the props. And then it's got two higher order components that it provides. One provides just the component that you pass in with the locale that you're currently using, coming in from the... does this work? Is there a shiny thing? The shiny thing doesn't show up on the screen. This is weird. I'm not going to use the shiny thing, therefore. Yeah, and with messages provides you with a part or one specific message from the message object as a prop that you can then use in your component. Now, the idea with this talk is I'm not going to dive into the code and of what goes on here. So there's going to be a lot of code on the screen, and sorry about that, but also this is one of the best ways that I found for explaining the thoughts that I went through when designing this thing to see how to use this create context thing and what can you do with it, and a couple of the other features that came in with the 16.3 release that actually link up pretty well with the context API. So to start with, this is where I'm getting my context from. There's a single file. I've got a default value, some locales, an empty array of locales, and an empty object of messages. And then I'm just directly exporting from here the consumer and the provider that I'm getting out of this. In this case, it's entirely possible for me to use the same consumer and provider in a couple of for all of the message providers that I'm creating out of this. Because you end up, if you have multiple providers within each other, it picks the closest one. But it took me like 3 iterations of writing code to figure out that this is the right way of doing it. Because or the simplest way, at least, of doing it. And then this is the provider that it's bringing in, as you see, the default value and the provider from the message context. Path type is just a prop type shortcut that's not really that important. And the message provider then, as mentioned, it takes in the fallback, the locale, and the messages. Internally, as you saw here, the default, the value of the provider that it's hanging on to has just 2 values, locales and messages. The first value in the locales is the current locale. This allows for some easier operations inside when you're dealing with fallbacks. Because if you have multiple fallbacks, then it's easier to just iterate through one array rather than just have a one locale and then a fallback array. But there's some juggling that needs to happen in the message provider to get there. And now we get to another feature that's new in React 16.3, which is the get derived state from props static method on a component. Effectively, this is a replacement for the component will receive props method. All it gets is, as input, are the new props and the previous state. And handling just those as a static function makes for a cleaner interface. This actually gets called also after the constructor call. So you don't have to duplicate functionality like you usually end up having to do with a constructor, and then a component will receive a props method. So the first part, the locales there, is just building the locales array out of the fallback and the locale. And then the next part there is checking whether we actually need to do a state update or not. Because obviously we want to minimize the number of state updates, because each of those ends up creating a re-render, so we skip those. And the state, again, gets the default value that we plugged into the provider originally. And then the render of this is just a wrapper around the provider that we got from the create context call. Get messages is a utility function. Get in is effectively the same as an immutable map get in method. So you can plug in a path of steps and access a value deep within an object, and it doesn't throw if there's a middle object missing somewhere along the path. And that's used to create this get message function that's then used in the message component. And the first part is just building up a locales, the path from which we're looking, because we need to do some special handling on depending on whether the whether we are using a multi-locale or a single locale data structure. And then we check if we can get the message, and if we don't, then we return it. If we can, then we end up returning it, or we just say that, no, can't find it. And this is then used in the message component that we're building on top of the consumer component. And this, it's using, as you see, the get message method, and it's getting the consumer from the context that we created. And the message props that you can see, and those end up here. We build from the props a lookup for which locale we're looking in, and then we try and look for the message there, and depending on what type of what's the type of the object that we end up finding, we do a couple of different things, because as I mentioned, the message params that you can see gets passed in. And those are parameters that you can pass into a function, so that if you have a value that depends on some variable, then you can build that using the parameters coming in. And then if we don't find anything, then we just call the on-error callback that can be passed into the message. Or then and if that returns something, we return that, or then we just return the ID that got passed in originally. So the point here is that the user sees at least something sensible, or the developer sees at least something sensible about what's happening. I'm going to skip the with locale higher order component, just show you the with messages higher order component that's then included here as well. And what this does is it takes in a couple of parameters of what exactly is the message, part of the message structure that you want to pass in. And then if there's some specific locale or series of locale fallbacks that you want to use those. And then it takes in a component and returns another function ends up it's a whole pile of functions all the way down the way that React quite often ends up being. And you end up with this sort of complexity. And about half of that is just so that at the right sort of level, we can plug in the render.display name for the thing so that we can get a nice message in the React dev console and elsewhere about if or when this thing fails, about what is the thing that failed. And one interesting thing to note on the last line there is the forward ref, which is another reason for the complexity here, because that's yet another feature that came in 16.3, and what that does, it enables the ref to get passed basically through this component to what's within it. Because normally if you're working with higher order components and you try and get a ref to the thing that's inside the higher order component, it ends up being a bit fiddly to get that to work. The forward ref does magic for you, so it just works. And that's it. That's the entirety of the whole, that's like 95% of the whole code that I just showed in front of your faces there. And it was a lot of code. I'm sorry, that's not how I usually do presentations, but I could not figure out a better way of talking my way through this, showing you that you can build really nice and minimalistic APIs using create context, like this one. If you think this one might be useful, you can install it now. It's published. I think I'm 0.2.0 version that I've released out of that. But yeah, thank you for your attention. Any questions or comments?
Yes, what was the reasoning you chose to use higher components instead of render blocks?
Because I could do both. Because I'm providing both the message component and a higher order component, because what I'm doing with this is providing a tool so that if you want to use a higher order component, you can. If you want to use a message component directly, you can.
Like, what are your thoughts on the? You said at the start that the context API is going to replace, the Redux thing.
Some of the use for Redux, yes.
Yeah. What are your thoughts? Like what in which cases it would replace it? And
Most. Honestly, that is most of the stuff that you end up using Redux for is passing data around and handling data in a nice manner so that you can think of having, this is my data, this is how I display my data. This breaks that paradigm of sorts because it makes it easier, much easier for this is how I display my stuff to also contain the logic of how to handle the data. So you can have a React component that is doing the data handling for you and have stuff happen through the React component methods, component lifetime methods, rather than having to figure out how to integrate Thunk or Saga or other side effects with your Redux store when you do changes and operations.
okay, so basically, have you checked is the behavior the same? For example, if you dispatch an action in Redux, it always launches or invokes all the listeners and stuff like that. Like, is it the same in a sense?
You can end up having the same functionality, of course, because the logic and the paradigm of how stuff is working is different. Yeah. Because at that level, with context, you end up at some level just having props and state that is holding the data that you used to have in Redux. So React provides the methods that when the lifecycle methods, so that when changes happen, you can do stuff with the new state or the new props and handle those. Yeah.
Probably like still Redux for the backwards compatibility instead of like using the 6.3 stuff?
That depends on what you're doing. If you're writing your app that is an end result of the whole thing, then you get to pick which version of React you're writing it for.
Like libraries, if you're writing libraries, it's maybe.
If you're using functionality that is provided by libraries that depend on Redux, then there's an obvious reason why you would do that.
Yeah, but also because these require the newest React version. So if you use something else, then you can maybe support also easily the older versions of React, right?
Yes, obviously, if you're using 16.3 version, 16.3 features, those don't work in React older than 16.3. But yeah.
So you pass the value. So you pass the state of the parent component as a value into the provider, and then you get the context out of the children. So is there any way that you pass some object which is not like the state of the parent component, the provider? And if that's the case, then how do you trigger the change in the value and it results in the re-render of the child component?
The child component is inside a consumer, and the consumer is effectively what the consumer provides you with. Here. Yeah. It has a render function that you're then using. And so the child component that I believe you're talking about is in the render something part there. Yeah. And what that will, when an update happens, the value passed in as a prop to that child component will change. And that will trigger a lifecycle method for the child. Yeah, right. And then you can grab it there. Or you can grab it wherever you're storing it and passing it in to the provider, depending on how your own logic ends up working.
But my main question is how do you update the value that you pass in from the provider how do you change the value of that you pass in the provider from the consumer?
You have the provider within something that has a state, and the state is then passed in as a prop to the provider. Yeah, right. So you have to have that something, where you're handling the logic of the API calls, for instance, and other parts.
So what if you pass in another object which is not a part of any parent component? So that's not going to work, right?
Okay, this is the last question. You can continue the conversation afterwards.
Yeah.
If someone has a separate question, maybe one more, and then let's continue. All right.
Thank you for your attention.
I can. Can you hear it? Does it work? All right. Cool. Hello, guys. Hello, beautiful people. So the dreaded D word, documentation. I know this is not the sexiest topic to talk about probably, but I hope this is going to be educational in terms of how to do it and what are the things I've learned through being on many different projects in my experience. So let's start. My name is Margarita. I work as a consultant at Futurize. If you work at any consultancy, please raise your hand right now. Okay. Raise your hand if you're new to the project that you're working on right now. Like if you just joined the team and you're new. Okay, so there is a few people. If you're any one of these, you probably know the struggle of being on a new project or starting a project yourself or actually getting an old project from the previous owners. I think it's especially relevant for people who work in consultancies, but of course it also happens internally in the companies. And why I want to talk about it is because I believe there is a huge lack of the dreaded documentation that nobody really wants to write. Of course, it's not a very common thing, but in many cases, when you are on the new project, the README file looks something like this. Just npm install, npm start, go F yourself. That's usually how it works, because people have a lot of assumptions. I think people have a lot of assumptions about what kind of stack other people are using, what kind of technologies people work or didn't work with. And I think it comes from the place of an ego, really. So what is happening is not really good, because, for example, when I was starting, when I was a junior developer who didn't really know really well how to build a project and how to like put the chunks to get together and build it, I was struggling. I was struggling a lot because there was a huge lack of information. People would presume I know a lot of things that I had no idea about. And I don't think it's just for the junior developers. I think it's a general problem for many developers, especially in the front-end world where things change really, really quickly. Like in a matter of a week, some framework can be outdated and there is a new, shiny, nice thing, which is like new React application library framework or something that everybody wants to use all of a sudden. I agree with Brad Frost, and of course, that's a huge, huge overstatement, but I agree to some extent with this tweet. There is a lot of assumptions going on here, like just install this, just run this command, just use these 5 scripts. That's too much. When it comes to documentation, people seem to remember about it only when there is a lack of it, only where there is nothing, and only when the deadlines are approaching, people seem to remember, oh, sorry, we didn't document that. Oh, shit, I wish there was more documentation. I think a good example was, at least in my career, a good example was Autoprefixer, a really nice library that adds vendor prefixes to your CSS. And there was a huge problem at some point with Autoprefixer. I couldn't figure out which versions of the browser's specific prefixes supported. Meaning that inside of the tool, which was supposed to do the browser compatibility, I couldn't check which browser compatibility is gonna be used. Like that was insane. There was no way to find out from the documentation. And that's actually a big problem. Usually the excuses include, but not limited to, we didn't have budget or time to write the docs. Everything is in package JSON, just read that, you'll be fine. New developers can always ask me about everything. It's all in the code base, like there is comments in the code, like I don't need to write docs. It's your job to figure out how to do it. Like if the code was hard to write, it should be hard to understand, right? That's how everything works right now. So why it matters? First of all, people leave the companies, people leave the projects. That's the reality. Developers change jobs quite frequently. And if somebody wrote this nice, shiny piece of code that nobody understands how to read and then left, that's a big problem. People might not be familiar with that specific tech stack, and This is actually a very common case in the consultancies where people take over the projects really quickly in a matter of days. Junior developers have no idea what to do most of the time. And on large projects, specifically if you're developing something during a very long period of time, you kind of lose track of what you're doing yourself. So I think we all can benefit from having really nice, shiny docs in the project. And a disclaimer is that is my experience. Of course, some people might have more experience with specific technologies and projects. I'm going to speak from my own position here. So let's get started. Here is the case, a very realistic, practical case that I had. It was a very short-term project within Futurize. It was only 3 weeks. I was the only front-end developer on the project, like all alone. And I had to do a handover, and I knew that I had to do the handover in 3 weeks to a backend guy who had no idea about React, Webpack, Node.js, JavaScript, nothing like at all. So this is the actual project. You can go to the website aita.ai and check it out. The guys themselves created an incredible startup that uses a very sophisticated AI algorithm that allows you to analyze the database and do the predictions about the consumer side, like future purchases, what kind of stuff is going to be relevant. You can do search with that. It's a really great, sophisticated tool, and they needed to ship a website really fast. So I had only 3 weeks for literally everything, and by everything I mean React.js frontend, contentful integration, Webpack 4, style guides. In this case, I used Sass because why not? And the docs. And the docs was a really big point here. And I realized that, okay, nobody knows how to write docs. Literally. There is no like good specific guides about it. And this is my approach to it in this presentation. So first of all, you have to use good, comprehensible commit messages. You can go to Git Lost Twitter account. This is how you should not do commit messages. Git Lost basically scrapes GitHub account and gets the swear words out of the commit messages and posts it to your Twitter, but don't do that. This is what you should not do. I think one of the best guides that I've personally found on the internet is how to write a git commit message, and this is the URL, and I've been using it a lot at work, and it works really nicely for different teams, so I guess it's more or less agreed upon solution. Good issue descriptions and links to corresponding commit messages. That would work more or less for bigger teams, like when you work with at least 2 or 3 guys inside of the team. You create an issue, you link to the specific commit message that solves this issue. It's a really great way to communicate without actually having to do any real-life communication. Well-curated config files. That's actually really important, and I'm not trying to push any specific bundler or any specific tool here. I'm just saying that in general, having a very hack-ish free, nice config file solves a lot of problems. And I'd say it's better to spend a little bit more time doing your config file to configure all of the processes and streams nicely, so that later you can only concentrate on development and not, hot fixing some issues that emerge because of the wrong config. Clean your package JSON, which is also very important because in many ways we import old libraries or libraries that don't actually work for our project, and we then just forget to delete them from the package JSON. So what happens later, we just download a bunch of NPM modules that make the project heavier without really a need for it. So NPM prune is a very good way to remove spare packages. And there is actually a library called Cleanup Dependencies that I haven't used, but I've heard good things about it, to actually remove the files mentioned in the package JSON that you're not using in your own project. always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. I think John Wood said it. There is different resources who tell different things about who said this quote, but it's very true. If you're wondering, oh, come on, there were no violent psychopaths. I am the psychopath. I will find you and I will kill you. No, it's a joke, but honestly, a good code is already half the way through to having a good documentation. So yes, please do it. When it comes to docs, README MD is the king. Like everything that I need to know SAP about the project should be in the README file. It should include as much as you think makes sense for the specific handover. But I would describe the approach in this way. If you start doing your documentation from day one, like literally you just created the project, and you just kind of throw everything you have into the MD file, whatever, it doesn't have to be pretty, it doesn't have to be really well curated, it just has to have a lot of information that people can find. That's already a really great start. Because when the project has like 16 modules and 5 databases and 28 views, and that's kind of late to start the documentation, and that's when the documentation fatigue comes in a room. So that's why it's much better to have a little bit from the start than to kind of redo everything when the project has evolved already. So what I did here, what I think should be included in the documentation is actually very simple. Small project description, critical scripts that you should run for testing, starting the project, maybe some specific dev version of the project, so those ones. Links to blog posts used in development, because let's be honest, we all use that, right? Architecture schema is really helpful most of the times. Critical hacks issues, it's like a compulsory thing to be included. You have no idea how many times I heard something like, hey guys, sorry, I think this test fails. Was there something wrong I did? Oh no, it's been failing all the time. Oh yeah, sorry, I forgot to tell you. So to eliminate these kind of situations, it's very good to document it, and for yourself also. ESLint guide, because yes, and data model. I will cover some of them separately. So small project description, 2 sentences is okay. Like you don't have to go nuts and write a poem or blog post about it, just as little information as you can provide at this point. Critical scripts, like that's what I have here. I think it works because the backend guy who is taking over the project is going to know how to launch it and what to do with it and what to Google, at least. Webpack in this case. Links to blog posts, yes, because we are all using it. And a lot of projects have been built using different sorts of blog posts, like kind of chunked together in one way. So that's a good resource to start with. And it literally is a matter of seconds. You just copy paste a link of the blog post and that's it. Architecture schema, like maybe it's a bit of an overstretch, but I usually like to include this type of images there just to kind of make sure and tell the guy everything is fine. If it looks like this, it's okay. Just to be extra sure about how the project works. Critical hacks. For example, I use a lot of ImageMagick tools to minify the images. And it's not a part of a build process, but I still used it. So to me, it was a hack. So I included that into my README file. Improvement suggestions. What I did there, I just listed some kind of suggestions for the animations that they can include later in the website if they want to, that were compatible with the system right away. So why not? It helps them in the future. There is actually a really great tool. If you saw this type of files, it's a screenshot of my Markdown file, and there is a great plugin called Markdown Editing for Sublime Text, which makes your Markdown file in Sublime really pretty and nice to work with and write documentation at. So why not? To do file, it was a very small project in my situation, so I didn't want to create separate issues. I have a board. I I really like to keep everything in one place. So you can create a small app.todo file and have all of the tasks there for yourself. There is also a plugin for that for Sublime Text that allows you to kind of check box the things that you have done already and see what has been cancelled, and it actually logs the time and the dates when you have done it. So it's a really nice tool to keep track of the project pace for yourself. Frontend MD. It generates some parts of the documentation for you without you doing it manually. So I highly suggest you to try and use it in the future. And since we're at the React meetup, I had to somehow connect it with the React project. So I came up with the React tools. I've personally been using Storybook, and I actually taught designers in my team to use Storybook to check how the components are going to look like on the web, because we had some designers who knew CSS, so that was completely possible in my situation. I highly advise to make your designer learn Storybook at some point, because it's a really great tool of keeping track of your components in the project. Very similar is React Style Guidist. It's Storybook, but React Style Guidist, if that makes any sense. You just basically mark down the documentation of the components, and then it creates a component in React modules for you that you can kind of reuse and put together like a puzzle. I'm really briefly going through them because I'm pretty sure you can read better the documentation online about how these two work. And as a conclusion, I really like Tom Ford and his design, and he said at some point that dressing well is a form of good manners. And I'd like to paraphrase that and say that good documentation is a form of good manners among developers. So thank you. Any questions? Yes.
There was a tool called frontend.md or something.
Yes.
Is it like an alternative for JSDoc?
Sorry?
Is it like an alternative for JSDoc?
I think they work a bit differently. I think Frontend MD creates most of the documentation for the styles, and it generates it automatically. And also, it creates really nice schemes for your JavaScript modules. So it will literally be, it will draw you a tree of how your components are included between each other. So that looks quite promising, at least to me. Yes?
Any other questions?
Questions?
Well documented.
Thank you.
All right. Thank you.
Thank you.
Let's have a 15-minute break and then continue.
Problem with me for TypeScript is that type inference, but I'm gonna talk about that. That you have to type everything, and I find it kind of annoying. And then in most cases, or in some cases you type any, and then with any you basically lose all the type safety further down, and then you're like, ah.
With reason you can't do that.
You can. It's really tricky. So most people rather type it instead of, and it like in most cases you have type inference, and it actually like does it automatically. But let's get to that in a okay, with two friends of mine. It's ReasonConf in Vienna, which is going to be in May, and it's the world's first ReasonConf. So you can see I'm a fan of Reason. But yeah, thank you very much for having me. It's a pleasure. I'm gonna be at React Finland next week. Who of you is going to be at React Finland? Raise your hand. Okay, good amount of people. Cool. It's gonna be fun, hopefully. Yeah, and today I want to give you an introduction, basically, to Reason React. So the first thing, who of you has heard about Reason? Okay, some. Who of you? So Reason is basically another language that compiles to JavaScript, and Reason the syntax is very similar to JavaScript, so it should be fairly familiar to pick it up. Who of you has used Reason, actually wrote some code? Okay, only very few. So first thing, don't panic. It's gonna be new stuff. You're gonna see like a screen of a lot of things. I'm gonna walk through it and explain everything on the way. If you have any questions, like just ask them. Raise your hand or shout at me, whatever works, to get your questions answered. Because yeah, it should be about you, not about me in this case. And yeah, let's get right into it. So what's Reason? Reason is a language, but why? Why do we need yet another language to save us all? Well, Reason aims to be 100% type coverage. You can bail out if you really want to, but it's tricky, and usually most of the time you don't do it. So what I just mentioned in the discussion is like in Flow. I've used Flow in the past. To be honest, I haven't used TypeScript more than just fiddling around a bit. But usually you go like at some point you run into a situation like higher order components. You can't really type it, or you have a hard time. Then you type it with any, and then like all the type safety that you got inside basically is gone suddenly. Like because yeah, there's no there's no safety from the type system anymore. So that's good. But the what annoys me with type systems, because I've done Java and when I was studying, is typing like I have to type everything, and that's quite annoying. So Reason has really, really good type inference. And what this means, I will explain in a bit. But basically, the compiler is really, really smart and can help you a lot to figure out what the type is without you actually declaring what's going on. There's no null or undefined exceptions because simply there's no such concept as null. There's a unit type, which is one thing. It's like it's basically something like undefined, but it's type safe because this none or undefined is like there's only one element for the specific type. So you usually use it for side effects. And I'm gonna go into that. Yeah, and most of the data structures are immutable by default. And over the last couple of years, I learned the more I build bigger things, I learned like immutability actually helps us because like if you look at the code, that's what it is, and you can look up further down, and that's when it was declared, and that's it, and it hasn't been modified by something else somewhere magically, and you run into race conditions. And the last thing where I'm really, really excited about Reason, and I already mentioned I'm definitely a fan, so be very careful to follow my advice, is variance and pattern matching, but I'm not gonna go into that. Okay. Before we see the first Reason React component, since this is a React meetup, we're gonna explain it through React. Reason is the language. Bucklescript is the compiler, which we're gonna see in a bit. And Reason React is basically bindings to the original React library. So to give a little bit of historical background, who of you know the name Jordan Walk? Okay, not so many people. That's interesting. So Jordan Walk is the guy who actually built React the very first time. He's the inventor of React. And he built it he actually didn't build it in JavaScript. He built it in I think it was standard ML. And then he showed it to his colleagues at Facebook, and they said, "Yeah, that's really cool. Let's give this a try." And now, a couple of years later, we are there and using React a lot. And his whole idea was to allow building user interfaces more functional, in a functional manner. And John was for a long time on the React team, and he built React DOM and other things and so on. Eventually, like basically what he was doing, if you see a spectrum from like getting UI, building UI more in a functional manner, he was going from like, no, we don't do it at all, to like, let's do React and push people more towards like functional style of developing user interfaces. And at some point he said like, okay, that's good enough, and come completely from a different side. And he adopted, like he built started this project, but now there's like tons more people actually working on it, inside Facebook and outside Facebook. And he basically said, like, we're gonna take an existing very functional programming language, which is OCaml, and we're gonna change the syntax to make it very appealing to JavaScript developers. And that's what Reason is. And basically, when you see Reason React, that's like where the things meet right in the middle. Because you have React, which enables us to build more functional user interfaces in a more functional manner. And with Reason, he basically comes from the other side. I give you a full language, type safe, immutable, all these kind of things that you want with functional programming. All right, so Reason React. Let's get right into it. We want to build a stateless component just rendering a hello world. That's it. That's how it looks like in Reason React. There are a couple things like that are weird, maybe, or like not common to what you're used to in a normal React React component. And the first thing is that I'm gonna switch right away to the editor because there we see it better. Can everyone read this? Is this good?
So was the creator
Sorry?
React or something?
What?
Like, was the creator of this language the same guy who made React?
Yeah, exactly. Yeah, that's John Wall. I mean, now, so Jordan is on the team. There's Cristiano in the team. There's Cheng Lu on the team. There's a lot more people working on Reason now. But as far as I understand, like he created React, that's for sure. But he also he initiated this Reason project within Facebook, and now he's working full time only on that. And the React team has different people. Yeah, so basically you have Reason React available. There's no imports. That's because the module system behaves differently. You basically, in our application, we have bsconfig, which is the compiler, as already mentioned. And if you define a dependency with Reason React, you already get it for free automatically in all your modules. This also means when we define an app file, app1 in this case, it automatically, if you use it in another file, in this case our index file, it automatically figures out, oh, there's another app1 file, which is a module. A file usually is automatically a module. And that means I can take that right away because it understands it through the type system. The compiler knows that. So you don't need to write imports manually, it just figures it out. So we create a component, and then we spread it out into a make function. And that's what really matters for every Reason React component, that you have like a make function, because that's what's publicly visible. And the only thing what we overwrite of this existing component is just the render function. It's a function. This is how functions look like in Reason. And then we have JSX. So we have JSX with the help of Babel, but also in BuckleScript built-in JSX exists. And I just overheard a discussion about formatting, that Go is so nice because Go has built in the format, or they clearly defined how a Go program looks like. And Reason is doing the same thing. They have reformat. I mean, you can, same as with Go, you don't have to use it, but usually everyone does. And that means whenever you do something like this and save, like that's in my case, you can run this as pre-commit or while you type, whatever. It formats it to the same style. And that means no discussion about code style whatsoever. Yeah, and then one thing, because of the type system, that is yeah.
Yeah, so just a quick question about
Go ahead.
formatting. If you remove the comma after component, will it format it correctly?
That's a good question. No. So if you create invalid syntax, it can't format it. It has to be. I mean, if you do this, then it will format it, but it has to be valid. With semicolons, yeah. For example, here, no, it doesn't edit because it's invalid again. If I forget it here, it will figure it out. Yeah. So,
I'm just kind of
yeah.
better
Yeah.
in some way.
Does Prettier do that? No. Yeah, same problem. Yeah. Yeah, I remember. One thing that's special about Reason React is, or the Reason React JSX, you can't simply put strings somewhere in the middle of it. You basically, everything when you, this in the end compiles to, even in the JavaScript world, to React.createElement. To fulfill the type system, a React element only can accept an element because the type system has to match. At least that's the case right now with how the Reason React bindings are written. And so we have to type this. Usually what we do in our projects a lot is just create a helper. And then you can do simply this, and that's easier. You could even make a helper that is like this, and then that's a bit more convenient. But I wanted to write it out in this case explicitly. Cool, so far so good. So if we now, this is basically my app. It's just straightforward package JSON. I get reason React from npm. I only have to tell BuckleScript, the compiler, that make sure you use reason React. But in the same project, I'm using Webpack. Everything straightforward. It's just about the language enhancing your experience. And yeah, so I can first of all like yarn start to run the BuckleScript compiler, compile everything, pretty straightforward. And then in this case, in this tab, I run Webpack. And what we can do then is, let's close this. We actually have our hello world here. Let's change something to do this. And if you refresh, we see this. So straightforward. Cool. So that's all you need to do. Go ahead.
Yeah, so this string element doesn't create like a JSX element, something like a span, or it just makes a string?
That's a good question. I don't know. What we can do, so if you look at this, yeah, it creates a React element. Yeah. So that type. I don't know what it does under the hood, but the result is of reason React dot React element. This is the type definition. Yeah.
Can't you just inspect
What do
the
you?
web page and see?
Yeah. I mean, on the web page. Yeah, on the web page, it's just a string still. Yeah.
Okay,
Yeah, that's for sure. Yeah, but for the type system, you basically need to tell it, hey, that's a React element. Yeah, I'm still wondering, to be honest, they could change it to why not accept just React elements and strings? But I will ask the team once I meet them in Vienna at the ReasonConf. That's a good question, because that would simplify things and make it more similar to the React JavaScript JSX version. All right, cool. I think that's still straightforward, not too much magic. Let's do some more fun, and we're gonna go into App 2. App 2 is something that comes with Reason React that you don't have in React, and that's a so-called reducer component. So what the Reason React team did is they actually built this kind of like mini Redux into Reason React itself, but at least from my opinion, this works way better in Reason React because you have things like variants, and I explain that in a bit. But let's take this apart step by step. I go through the first line. First of all, we're gonna define a type state. So if you use TypeScript or Flow, that should be pretty familiar to you, because you basically declare like kind of an object type. And we can do the same thing in now I'm gonna use rtop, which is a REPL, just like I can do the same thing in Reason. So I can declare type person, which has a name and an age. And what I can do with this type person is, for example, I can create Tim, and I can say Tim is of type person. This is how I do a type declaration. But what I also can do, and this is exactly where type inference comes in, and this is where it, at least to me, gets really interesting. I can leave out the type declaration and simply declare a variable, and it will, it's actually a let binding, it's not a variable, and it would automatically infer, that's type inference, figure out like this only, what you did here can only be a person, so it must be a person. And how this works, for example, if you leave it out here and just have a name, it will figure out like, well, this is close to something that you defined, like person, but it's not the same because age is missing. And this also means you can't do completely dynamic, let's do, I don't know, foo, and you can't do completely dynamic objects because you first need to declare like what kind of type does it have. there is a way, there's something in OCaml or like reason that is completely dynamic, but for like most of the cases you don't use it because this is, you actually want the type safety most of the cases, and this is actually helpful. Cool. So what we did here is we declared the state, and let me actually, before everything compiles, what we see here with this reducer component, what we build is a mini app that simply is a counter we can increment and we can reset. And to count, we basically need a count and store that in a state. And then in the state, in the initial state, here we declare the initial state, and we now could declare that the state is of type state, but we don't even need that. And now a really interesting thing, which is the type action. But as you can see, it's not like a record that you declare its structure, but it's actually a different data structure that if you're coming from JavaScript, you haven't seen that. You might seen it in a similar way, but not like this. And the action, it's a so-called variant. It's a data structure that allows you to do basically like this or that or that or that or that. And you can do as many options as you want, and they're exclusive. Let me demonstrate this quickly using here. So you can, for example, declare a type answer, and then you have answer, and the answer could be either yes, no, or maybe. Or enum is very similar, but I will show you the difference in a bit. And then you can say, okay, is the reason great, or is it raining? You can both bind these variables, and then you could do generate a message from that. So, and that's you simply put the variable or the binding into a switch statement, and then you can match on that if yes, no, or maybe. Pretty straightforward, nothing too magic. But the great thing about it is that you can it's basically what we do with Redux, and that's actually where Redux had the idea from this kind of variant type kind of style data structure. Because with variant you also have actions, and actions can have a type, and usually you assign it to a string that is uppercased. But what's different though to Redux actions is that Redux actions actually contain data, but so do variants can, and that's the difference to enums. Let me quickly show that, because what we can do is when we define a type answer, we can say maybe can have a reason attached to it or an explanation. So we can attach a different data structure basically inside as part of the enum. So it could be the yes, no, or maybe, and then you have a string. And how you can use this is your joining would be simply maybe, and then you call it like, it's like a constructor. You basically invoke it and you create an instance of it. And once you did that, you can, again, pattern match on it and use this. And then you can simply, what we're doing here is we say, we assign a message based on this switch expression, where you basically extract, like, if it's yes, convert it to this. If it's no, convert it to this. If it's maybe, extract the value inside of it and concatenate it with what you see here, basically.
Can you switch between like, or could you have like maybe with reason and maybe without reason?
Yes.
So
I mean, so you can't have maybe with a reason or without a reason, but you could have, what you could do is, and there it gets, or to that one. Let's say I do, I have the string, a very simple one, AA, But then I can do pattern matching, and I can say, I have to do this here so it doesn't evaluate. But with pattern matching, I can do things. I can not only extract, but can also do exact matches. So I can say maybe if it's exactly the string AAA, then not sure, but it was AAA, you know.
And you can have one with without parameter.
Well, no, yeah, I can. So if I wanna do one without, I mean, I can't have without parameter because it's a type system. There's option. I'm gonna get to that. Yeah, you don't have null available, so it has to be something. You can have an option, which means like it's something or null or like none. But we get to that later. How about the time? Is it fine if I go on first a bit longer?
Yeah, just go on.
Okay. All right. So yeah, you can do these things. And the really great part about a type system and these compilers is, for example, if you forget a case, and this is where it gets really interesting, is the compiler will warn you. So it tells you it didn't match, it wasn't exhaustive because you forgot the case. And this is extremely valuable if you have a code base. Think about the Redux code base where you match or where you reduce a set of actions and suddenly you introduce one more action. Now you want to know every place or you want to make sure you don't forget to reduce this action in every place where it can happen. And this is super useful for like evolving a code base because the compiler will tell you right away, hey, you took care of it in these two places, but oh boy, you forgot. There's one more case where it really matters. And this is the big value of a type system where when you have such data structures and you pattern match in them and extract and you get things out. So far so good. All right. We are at line 6 in our example, reducer component. I told you. Let me tell you that the rest is less intimidating. So what did we do? We defined the state, we defined the actions. Our actions are simply increment and reset. Then we take our reducer component, we declare our initial state, we create a reducer. If you're using Redux, you're probably familiar with this. You basically have like action, you have the state, and then based on the action, you can say if it's increment, update my state and increase the count by 1. If it's reset, update the state and reset the count to 0. And that's all you need. And suddenly you have like the magic of Redux inside a React component. But the benefit here is like if we say reduce by 1, the compiler will give me a warning here that you forgot to actually care about it in the reducer. Yeah.
But don't you have any plugin to the IDE?
Yeah, if you can, then that's good.
But there isn't at the moment.
I don't know any for Redux. Yeah.
No, but I
Oh yeah.
Yes.
Yes. Usually it would. The only problem is I do a lot of ACAD lessons, and then I turn off every warning, every auto-completion and so on, because if you speed up videos, then it interferes with it. So right now my editor is a complete mess. Yeah, I have to. Yeah, normal days. That's why I actually opened VS Code, because right now my Atom setup is broken. Because in VS Code, if you take the standard setup, you can do things like this. You just hover, and it gives you exactly all the type information that you need. And that's pretty cool because you can see, oh, what's children? Oh, it can be of any type. What's component? Oh, there's a lot of stuff in there. Or like it can be certain things. Let me take this example. You can see the action can be increment reset, and we can actually see here.
For example, if you remove the increment now or something, can you see that?
Yeah.
Yeah. Okay. Good.
I should not save that. Cool. Yeah, and then the rest is simple render again. And I mean, that's a lot to take in, but I want to give you a glimpse of like the power of it, what would you get with Reason React, really cool stuff. Yeah, and then the rest is just a button, on click, you get an event, and what you do is, instead of how like with Redux, you have dispatch, you simply do send. Yeah, cool. Yeah. No. Self actually refers to the instance of the component. So because it's a more functional style, you don't have like a this available. So what they do is they pass in self, which is kind of like a representation of this, and then you can do things. But it's also typed. So you, I have to go here again. So you see what it contains and what it has. Yeah. And yeah, and then you have this application. Pretty straightforward. Cool. Let's go into prop passing. No, I probably skipped that because we're already a bit late. One thing I want to highlight though is that Reason React doesn't mean like suddenly you have to rewrite your complete code base in one stop to actually make it work. Because what you can do is they made really nice interop to actually render a Reason React component inside of React, any like JavaScript React application, but you also can take any normal React component and render it inside Reason React. And to demonstrate this, we're gonna switch to app 5. And in app 5, what you're gonna do is there's Reason React comes with this helper function, which is called wrap.js for Reason. And what I wanted to demonstrate is, what I wanted to do is, I basically got out the, I installed a UI library called Rebus. Let's see if it's here. Yeah. So it's a JavaScript written. Actually, let's go. Yes, he does some magic there, but it's in the end like the output is just plain React components, JavaScript style, and I installed it in npm. And now, if I want to use it in my application, what I need to do is I can create basically a Reason React representation of this component using wrap.js for Reason. And if you look at it, it follows the same pattern, and that's the only importance for a Reason React component. Have a makefile that renders a component. And if you look at error, the makefile, it renders a component. And what we do here is we can simply get the rebus module from JavaScript. In our case, I get the arrow component that comes with this module, and then I can simply say the React class is my JS arrow, which I defined here. I can map the properties, and this is really important. That here, basically, I'm declaring like the property direction maps to the property direction of the rebus arrow, and then I pass in the children as well. So to use this in our app 5, let me close this one here. To use this in our app 5, you can see we can now, like with this little bit of helper code, we can use any React component that is out there. So you could have like draft.js and have a full bloated big editor in there that is like one component. you can use your existing UI library and still write type-safe reason React code. And then I simply pass down the direction, down and up, like I did here. Or if we change it, it would go up. The benefit here, and this is actually when I did a trial run on that talk, I haven't implemented that yet, but a friend of mine pointed out like the thing, like a string here, if you do left, maybe it's implemented, I never tried it, but no, left is not implemented. So if somebody is using this component, and that's one of my issues in JavaScript, like I don't know what this component actually expects. And this is a problem. And with Reason, with a type-safe system, what you actually can do is you could make sure that there's a type direction. Oh, no. And then it could be up and down. And then you could map up and down to the strings up and down. And what it would give you is that when you type in direction here, you could do arrow up. It will give you, like, the benefit here is that like you get exactly, just by hovering, you get the information, okay, this is an arrow direction, and it can only be up or down. Otherwise, the compiler will complain, hey, you're using a variant that doesn't work. And this is really, really helpful because everyone who is using your components, they automatically, like, they cannot use it in a wrong way just by declaring some kind of props. Yeah. And I think I'm gonna close at this point and call it a day. If you have questions, I'm gonna stick around for a little bit. Definitely, if someone wants to go out for beers for an hour, so also gonna do that. Yeah, happy to answer questions or exchange ideas. Thank you very much for having me. Questions?
You used a string of int in one app doc.
Oh yeah.
I was just wondering, how do you know that beforehand? If I'm a newcomer to Reason React,
Yeah.
and then I assume that I have number one, so I just make string to element, Reason React string to element,
Yeah.
and that number one. Does it work, or do you have to always to convert?
Well, what do you mean?
If you sort of counting example,
Like
can I explain?
this one? Because I used for up to. Yeah.
Yeah, string of int.
String of int, yeah.
So
So
if you use only self-state count into string to element, does it convert as a string, or does it?
no, it doesn't convert anything.
It
The
throws
thi-
an error?
Yeah, exactly. The compiler gives you a warning. We can actually, let's say, what would be an operation? Let's do concatenation of, like, we define a function, let name, and it accepts a string because let's actually do x, and then we say hello, and then x. What you can see here is, because I'm using ++, automatically the compiler understands, like, what this means, like, the argument must be a string, and whatever is returned must be a string. So now, if we call this function with a string, everything works fine. That's pretty straightforward. If you now call this function with an integer, it will tell you exactly the expression has a type of integer, but a string was expected. So it won't compile at all, but it will tell you exactly where it goes wrong. Yeah.
Yeah, but how do you know that you have to use
String of int.
read the documentation? And
Yeah. In this case, you have to read the documentation. I mean, it's a pattern. These are definitely things you have to learn, and that's onboarding. But it's always the same pattern. If you look, you can do the REPL and autocomplete, but you can see string of, and then you get all the possible. Yeah. So but yeah, that's definitely a thing with a type system like this, where you have to read the docs or figure it out.
It's not
yeah.
a problem. I was just
Yeah.
wondering whether it works without the type.
No, not at all, because it wouldn't be type safe anymore, and yeah.
True.
Yeah.
Like, how do you convince other people in your team or
Yeah.
company, you know, to use Reason? Because I haven't ever heard of somebody using it in production. You know?
Yeah.
So, like, how you say to your project manager or somebody who leads the team, like, hey, let's use Reason.
Well, I think it's. Let me tell you a story to that. It was about 3 years ago when a friend of mine, like, we were the only 2 guys in Vienna who we knew who were using React in production, and everyone else was like, this is crazy. You shouldn't do this. Like, you're nuts with using React. Then we did. He suggested, let's do a meetup, and I told him nobody will come. 5 people will show up. I was actually the negative one, and 30 people came because we're still interested, and they asked us for like 3 hours. We sat there and answered questions. A year later, we had 60 people on the meetup, and half of them were using React in production. I think I don't know. It's a really hard thing to convince someone who doesn't want something to switch over. The only way I saw it for in these cases is like show the hard benefits, like build a project, show it to others, and show like how you solved the same thing and had less stress, and it saved you in many ways. And yeah, it's a really tricky question, and I think it's also like, I mean, this stuff is still early. Same as like probably like, I mean, React probably 3 years ago was more mature. But this is also used in production. When you use Messenger.com from Facebook, more than 50% of the code base is written in Reason. So you see like a large production scale project is built with this stuff, and it works. That's one argument. If you need these kind of arguments, or there's also at ReasonConf a guy from Vienna who's working at Accenture. They actually approached us and they're like, yeah, well, we're using Reason in a bank, in the German bank. We can't tell much about like which bank it is and whatnot, but it's an internal project and we're using Reason there. And like, what? It's an enterprise scale thing. How can you adopt such an early technology? And it's like, yeah, they simply did. And yeah, I think it matters. Like, if you have the right team and the right people who are interested in that, then you can do it. But for example, right now I'm consulting a team in Vienna. I do a couple of hours to like help them get over the hurdle of like the craziest things they do, and I wouldn't recommend Reason to them at this point. It would be it's not the right thing at the right time for them. In a year or two, if like now they struggle with like they lost one of their front end leads, and now they have like junior person, and they struggle with to fix bugs everywhere. Reason clearly would help there. But like it would create so much of an overhead to that one guy and to the rest of the team that it would be crazy. But if they settle down and if everything works again and is fine, maybe in a year it's the right time to say like, okay, if we want to build a lot more features, maybe we refactor some of the stuff or actually build the new stuff in Reason to make sure we don't introduce more bugs. Yeah, so it's really tricky. I mean, and take everything I said with a grain of salt. That's the right phrase, because I like what we did is ReasonConf, the ReasonConf website. It's actually open source, so you can go there, and it's a Gatsby ReasonConf site. It's a static page, so it's not too magic, but there's a good amount of data that we actually pulled in, and so that's our data file where I have all the different speakers, and it's automatically shared between different pages and linked and whatnot, and the timetable is there, and the timetable is generated from you can see talk, you can see variants here with messenger, speaker, and whatnot. Yeah. So we have our fair share of experience, and made some good, some bad experiences. But yeah, I definitely would use it again. Yeah, convincing others is tricky, and yeah, not sure if it really matters on the context, if it's the right thing at the right time for you.
This top tool that you're using in terminal, it's Reason.
Yeah, yeah. So if you go to the Reason ML website, so there's also this thing. Nowadays, it's only called Reason, but before that, the syntax was like a couple months back. Now we had the Reason syntax 3, which looks very much like JavaScript. Before that, it was more like an ML language, and that's why ML is still. You will see this in a couple of places, by the way. But yeah, if you go to the docs. Global installation, you can get this Reason CLI, which ships with a couple of tools like the formatter, but also the arctop REPL. Yeah, it works as far as I know. Well, I don't have a Windows machine, but yeah, there was a lot of discussion and fixing. Windows is tricky.
All right. Any more questions?
One question.
Go ahead.
What about the number types? Which number types does language have?
Float and integer, as far as I know. Yeah. Maybe there's more, but yeah. To give some context, Reason is still compatible with OCaml, and I think that's still the plan. So that had a lot of impact on the environment, but it's also has benefit of that. Every OCaml library that is out there, you can basically pull in as a dependency, and there's some really good stuff. So you can, well, that's actually one thing I haven't mentioned, is like with Reason, you can compile the JavaScript with BuckleScript, but you also can compile the native code. And I mean, not if you wrap React or so, but if you could write, I know people who use OCaml GraphQL, and then they build a GraphQL backend or like GraphQL layer in OCaml and compiles to a binary, which means like it has a way faster startup time than any Node script, and which is quite interesting if you run it on Lambda or something like else to reduce cold starts. There's and also has CLI tools. I find like for the last 2 years I worked for serverless, and like one thing that it was always frustrating to me is like if you type serverless invoke and then for like 500 milliseconds nothing is happening because it loads so many node modules. I don't know. I care a lot about UX, and that's frustrating. And yeah, like if you do the same with a Go binary, boom, done. It's 2 milliseconds or so. Difference is huge. I mean, there is some cool stuff in the making. V8 has snapshots, so you can reduce from 200 milliseconds to 20 or so. But yeah, that is not a Node yet, and that might take a year or 2 or 3 or 4. Who knows?
All right.
Cool.
Any more questions? I guess. Thanks, Nick.
Thank you very much.
And just quickly, a couple of basic things to end with. First of all, huge thanks to Vincit for hosting. Then huge thanks to all of our speakers and for you guys for joining. Our next meetup is in June.
Yeah.
Yes. We don't know the date yet, but we'll let you know. Follow us on
Probably,
Facebook.
yeah.
Yeah.
There is a Facebook page if you haven't requested for access yet. Please do it after this or somewhere.
Yeah. Or follow us in Twitter. We'll also put it tweeted there. And if someone wants to join us for beers after this, I guess we can hang out for about half an hour here, or what does in this
had a meetup here. We hung out. You hung out here until about midnight. So half an hour is a bit, you know.
Then I guess half an hour is okay.
Half an hour is fine. If it's more than 3 hours, maybe then we talk after about 2.
Yeah, all right. But if you want to join us for beers after this, let's go to Kaisla. It's big and it's close.
And one thing more, next week there is Direct Finland. If you want to see something, please follow us on Twitter. We will be posting something there, probably. I don't know if we are, but please follow us. So React Finland is happening next week. There is going to be lots of after parties and whatsoever. Probably those are free to access and whatever. So please follow us and we will keep you up to date if there is some after parties. Yeah.
Yeah. Thanks. Hang around.
Yes.
All right.
All right.
Let's not go.
Now take